In this video, I'm going to walk you through lesson 2 of unit 8.1. Now, we ended lesson 1 with creating a list of ideas for investigations. And so we reflect on that list that we created and we prepare to investigate and take observations of other things that maybe students even suggested colliding. So this is a very fun investigation. And this is the slide that prompts students to think about what we're going to do to see collisions. We're going to drop things and we're going to break stuff. And so we set up a T-chart in our notebook and we are asking students to make descriptions of collisions. And then any challenges that they have with the investigation or questions that pop up, they're going to list here on this side of the T-chart. So once we set up our notebook, we then start dropping things and breaking things. And here are some of the things that you can put at each station. Rice noodles break very easily. You can use any type of pasta noodles. Heavy books and bricks, golf ball, tennis ball, marble, sugar glass. There's directions in the Google Drive on how to make sugar glass. This is very messy. If you have an ant problem, I do not suggest sugar glass. Soda crackers are better. One thing I will also say is soda crackers, maybe put them in a Ziploc, and so they can collide with soda crackers in a Ziploc. So the crackers are contained. Anyways, a CD case or a DVD case, but it's most likely going to get damaged. So just know that. Back to the storyline. So you're going to set up stations with all these materials and students are going to have way too much fun breaking things and dropping things. Make sure they have safety goggles as they do this. And what they're going to figure out, we're going to discuss our observations. And what we're going to figure out is that it was kind of hard to make observations because it wasn't a controlled experiment. We were just having fun, breaking things and dropping things. We noticed that things changed shape, things broke. We couldn't tell if everything did, but it was very difficult to find patterns and make observations. So we decide that we need a more controlled collision. And so we are introduced to the cart and track system that we will use many times in this unit. And we talk about controlled collisions. So here is the image that you're going to use in the slideshow to introduce the cart and track system. And you can see that there's a track underneath with this blue cart. And you're just going to talk about the different objects and the setup. And then we're going to do a station investigation. So there'll be several different stations set up. Let me go ahead and show you. So this is the setup you'll find in the teacher edition on how to set up the stations. First of all, each track is going to be taped down to the lab table. And then you will have a washer inside, depending on how heavy your carts are. It just helps it kind of move a little bit better. You will see that one of the stations has rubber stoppers attached to the front of the carts. The second one has metal rings. They're pretty flexible. The third one's going to be a golf ball attached to the cart, and then a CD is what you're running into. And then the fourth one, you're going to attach clay, modeling clay to the front. So this is going to help look for change in motion and shape. Students are going to complete a data table. It looks like this. So they'll list what station they're at here, what are the two colliding objects, and then of course just answer the questions about change in motion and then change in shape. And we're going to be looking at both parts of the system, the object 1 and object 2. So we come back together and we discuss what happens to the motion and shape using our evidence as a way to discuss what we saw, what happened with the cart system. And this is actually an end of day 1, beginning of day 2 in the teacher guide, but that doesn't need to be where your class begins and ends. You're just going to have this discussion about what happened to the motion and shape. And then we come back and we realize that maybe we need some additional sources of evidence because it happened so quick. It was hard to tell what was happening because the collisions were so quick. It would really help if we could watch this in slow motion. So you say, great, hopefully you got that out of students. That's great. I have some slow motion videos. And so then we move into, here are 3 slow motion videos. one with the golf ball colliding with the CD case, another with the carts and the rubber stoppers, and then the carts with the metal rings. So we watch it in slow motion, and students are going to make observations in their notebooks about the 3 videos. Again, looking for that change in shape and change in motion. After making observations using the slow motion videos, we come back together and we discuss with a partner or a small group what causes the change in the shape or motion. So here's the slide that will prompt that discussion. And then you'll get back together and ask a few groups to share what they think causes the change in motion or the change in shape. And really, you're trying to get to these sample responses to bring energy back to the front of our thinking. So they're going to share with their partners, and then you're going to ask a few to share, and hopefully they get that energy is being transferred from one object to another. That's what's causing the motion. And that one or more forces push on one or more objects, and that's what changes the shape. So we're bringing it back to the lens of energy and force, that energy perspective and that force perspective. And then we create a consensus model together describing what we figured out. This would be considered a building understandings discussion because we're really trying to summarize our learning from the investigation. And so the directions say to fill out these first 2 columns, and then you'll fill this out as you get ideas from students. And so before the collision, they're moving towards each other, or one is moving towards the other. The cause is that energy is transferred in that energy perspective. And then the effect is that the kinetic energy of each object changes. So remember that kinetic energy is energy of motion. And in that force perspective, there's no force between the objects before they collide. Then one pushes the other with a force when they collide. And then sometimes they change shapes, and sometimes we're not sure if they bend or shape at all, but you can see that there's some type of push. So we're coming to the end of lesson 2, and we're going to actually record our first entry in our progress trackers. Now, the teacher edition gives you this. It talks about what students will figure out. I will say first entries in progress trackers are pretty hard for students if they do them on their own. So often teachers start by doing this together under a doc cam. They get some of those ideas that are summarized on that chart, and then they write under the doc cam as students kind of follow along. But eventually you want students to put what they figured out in their own words. That's really that metacognitive practice of putting down what they think they know about what has happened. And you've got the chart to help them. So you need to decide how you want to scaffold that. But the idea is they write down what they know in their own words. Progress trackers are generally not graded because you don't want them to be nervous that they're doing it wrong. You just want their thoughts of what they think they have just figured out on the paper. It also shows change in thinking over time. And so you can really, again, that metacognitive thinking of learning, I can see how I've learned over time. There is a slide set up for progress trackers, but some people use a Google Doc and they do it digitally. Some people print out handouts. I'll put a link to a template down below that another facilitator I know created. And then, this is the slide. This can be modified if you want to do it a different way. But this is our first of our progress trackers. It is very important that students keep track of what they figured out and have that to reference throughout the unit. All right, that's it for lesson 2.